let's continue our discussion about conversion of number system. So in this video lecture, we're going to discuss decimal to any base. We have two procedures for decimal to any base, one for whole number and second for non-whole number. So let's start with for whole number. So for whole number, we're going to divide the given number by the base of the answer. So if it's base 2, divide by 2. If it's octal, divide by 8. If it's hexa, divide by 16. If it's base 3, divide by 3. Okay? And then we're going to get the integer quotient or the whole number quotient. It will be used for the next cycle. And for the remainder, okay, we're going to arrange it later. Okay? And then repeat step 1, step 2, and step 3 until we get a quotient equivalent to 0. Okay, so divide the given by the base of the answer, repeat it until we get equivalent to 0. And every division, so we're going to get the remainder. So what to do with the remainder? We're going to arrange it from most significant to least significant digit, or from bottom to top, from the last remainder going to the first remainder. So for example, we're going to convert 53 to binary. So binary is base 2. So we're going to divide 53 by 2. So we have 26, remainder 1. And then the whole number will be divided by 2 again. So 26 divided by 2, 13, remainder 0. 13 divided by 2, 6, remainder 1. 6 divided by 2, 3, remainder 0. 3 divided by 2, 1, remainder 1. And then 1 divided by 2, 0, remainder 1. Since the quotient is equivalent to 0, we stop on this cycle. Okay, and then since we already determined the different remainder for each division that we conducted. Okay, so now we're going to arrange it from most significant digit, which is the last, going to the least significant digit, which is the first remainder. Okay, so when we write this to our equivalent in binary, okay, so the result will be 110101. This is the equivalent value in binary of 53 decimal. Okay, how about for decimal fraction or non-whole number to any base? So instead of divide, we multiply the given by the base of the answer. Every time we multiply, we get a product. Okay, so separate the integer and the fractional part, and integer will be multiplied again by the base of the answer, and then separate again the integer and fraction, and then the integer will be the fraction will be multiplied again, and this will be a cycle until we get a fraction equivalent to 0. Okay, and then after getting fraction part equivalent to 0, we're going to arrange the integer or the whole number from top to bottom, from first integer to last integer. So for example, convert 0.375 to binary. So multiply the given by 2. So we have 0.75. The whole number is 0. Fraction is 0.75. So multiply it by 2 on the next cycle. So we have 1.5. Get the whole number, which is 1. And then 0.5 will be multiplied again by 2. So the result will be 1.0. And 1 is the whole number, get it, and the fraction is equivalent to 0. So therefore, we stop on this cycle. Now we could arrange the whole number from top to bottom, from the first to last. And don't forget, before we arrange, or before we get the equivalent in binary, kindly write first the radix points, because we all know that we are referring to a decimal fraction. So it's a non-whole number. Okay, so point followed by the first digit, 0, second digit, 1, third digit 1. So this is the final answer. Okay, so this is the equivalent in binary. Another example, again, decimal to binary. So let's convert 25.25 to binary. So since we have non-whole and whole number, so therefore we have two parts of our solution. So first, whole number, we divide it by the base of the answer until we get a quotient equivalent to 0. So 25 divided by 2, 12 remainder 1, 12 divided by 2, 6 remainder 0, 6 divided by 2, 3 remainder 0, 3 divided by 2, 1 remainder 1, 1 divided by 2, 0 remainder 1. Since the quotient is equivalent to 0, now we could arrange the remainder from bottom to top. So the result will be 1, 1, 0, 0, 1. Now we are ready to convert 0.25 to binary. So 0.25 times 2, 0.5. Whole number, 0. 0.5 fraction, multiply again by 2. So we have 1.00. Fraction is 0, so we stop on this cycle and get the whole number, which is 1. Now we are ready to arrange the whole number. So don't forget, radix first, radix point first before the first digit of the fraction. So 0.01 base 2. Okay? And then to get the final answer, just append the two answers. So we have 11001.01 as our final answer. Okay, now decimal to octal. So instead of base 2, now base 8, multiply 8. Okay, or divide by 8. So given 92. So we continuously divide 92 by 8. So 92 divided by 8, 11 remainder 4, 11 divided by 8, 1 remainder 3, 1 divided by 8, 0 remainder 1. Since the quotient is equivalent to 0, we stop. So now we're going to arrange the remainder from bottom to top. So we have 134 octal. Okay. And then 88.375, again, we have a separate process for the whole and non-whole number. So for the whole, divide by 8. So 88 divided by 8, 11 remainder 0, 11 divided by 8, 1 remainder 3, 1 divided by 8, 0 remainder 1. From bottom to top, 130 is the equivalent of 88. Now let's proceed with 0.375. So multiply by 8. So we have 3.00. Get the whole number, get the fraction. Fraction is equivalent to 0, so therefore we stop. So the final answer for 0.375 is equivalent to 0.3 in octal. Just append these two answers to get the final answer, which is 130.3 base 8. Okay. So now let's proceed with decimal to hexadecimal. So 100. So divide by 16 continuously. So 100 divided by 16, 6 remainder 4, 6 divided by 16, 0 remainder 6. Arrange from bottom to top since our remainder is, or our quotient is equivalent to 0. So we stop the division. So now we are ready to arrange our remainder. So from bottom to top, 6,4 will be our answer. Okay. And another example, 910.25. So we're going to have a separate processing or conversion for the whole and non-whole. So 910 will be divided continuously by 16. So 910 divided by 16, 56 remainder 14. 14 is more than 9, so we're going to use letter. 14 is equivalent to E. Then 56 divided by 16, 3 remainder 8. And 3 divided by 16, 0 remainder 3. And for 0.25, multiply it by 16. Okay, so 4.0. So 0.4 base 16. This should be base 16, not 8. Okay, it's just a correction. So again, 0.4 base 16, append to 38E. So this will be our final answer. 38E.4 base 16. Okay, so thank you for listening. Let's continue our discussion on the next video lecture.